All right, just a quick little video on finding domain. Apparently my dog was unaware I was making a video. In class we had a problem that was a little bit unique. I had a way to do it. Couldn't explain it very well. Didn't like the way I did it, but it was right. So here's my attempt to kind of correct that and get your mind thinking on the right direction to crack this code. So we have two problems here, really. We've got the issue of the square root. So remember that this is a square root, which means its index is even. So we have a problem where the radicand has to be greater than or equal to 0. So initially what we did, and if you want to skip past this part, that's fine. But initially what I've told you every single time is just you take the radicand, set it greater than or equals 0, and solve. Well, the issue here becomes that doesn't really help you, because what it comes to is a true or in this case a false statement. No, it's true, but that implies that all real numbers work. Well, that's not reasonable, mostly because we have a problem right here. Because it's a fraction, we can't have 0 down in the denominator, and so we have x minus 4 cannot equal 0, which means that x cannot equal 4. So then what's the answer if all real numbers work except this? Well, the problem here is that we're looking not so much for a value, but a sign. And so I want you to stop and take a look at this thing and ask it in words, and it will probably make a little bit more sense. So we have something is greater than or equal to 0, which means the something that we want has to be positive. If that's true, the only way to get a positive out of this particular thing is if these are both positive or both negative. The 3 does not change its value. This is positive. That says that this must be positive. In order to be positive, it has to be greater than 0, so x minus 4 has to be greater than 0. If we do this, we just add 4 to both sides, we get x has to be greater than 4. Now, in the original, we said, oh, but this can be the radicand, this stuff right here, can be greater than or equal to 0. And the issue that we had with that is if the bottom is 0, then we have a divide by 0 error, and it's undefined. That's why down here we said it has to be greater than 0. So it cannot be negative, therefore it has to be greater than or equal to 0, and it can't be equal to 0 because then we would have a division by 0 issue. So the final out of this is that x, the domain of f, is x is greater than 4. Or in interval notation, this is just simply 4 going towards positive infinity. It cannot be equal again because you can't divide by 0. So we have no or equal to here, which means the 4 gets a parenthesis, not a bracket. So these types of problems are somewhat unique in that there's a lot of different, in a sense, a lot of different number theory going on. So rather than just, I don't want to say brainlessly going through it because it takes some thought. But instead of just walking through the steps, you have to stop because the steps don't make sense here. So that's where you need to stop and think about what you really want. All right, this is about as messed up as they get. I would have loved this as an extra credit question on a test, let's say, but I wouldn't have given this as a homework question. So because it came up for those online, if you're going to do it on paper, I am going to have a problem extremely similar to this because they all look like this. Now, as a second half to it, I noticed that a negative came up. So you would have had like negative 9 over x plus 3. And we want to make sure that that's greater than or equal to 0. In this case, because the top is negative, the bottom here has to be negative. Otherwise, it will never be greater than or equal to 0. So since that part needs to be negative, that means that x plus 3 wants to be less than 0. And then if we subtract 3, we get x is less than negative 3. And so that's the issue there. So in this case, then the domain of if we threw this under the root, and this is the square root or a fourth root or a sixth root, an even root. If it's odd, it doesn't make any difference. You just have all real numbers, with the exception of this can't be 0. So watch out for that. But the domain of this stuff would then be x is less than negative 3, or an interval notation going from negative infinity to negative 3. And you cannot count negative 3 because it would create a 0 issue. All right, I hope this kind of helps explain what's going on with these styles of problems. If you guys have any other questions, let me know.